video, we're going to be working with the discriminant to determine the nature of the roots. When we say determine the nature of the roots, it's to describe how many roots there are and whether they're real or complex. So, first thing that I'd like you to do on your calculator or in Desmos, graph those three functions. We've got x squared minus 6x plus 9, x squared plus 8x plus 25, and x squared plus 8x plus 7. Go ahead and pause the video so you can get all three of them graphed. Once you have them graphed, they will look like those three graphs. So we've got x squared plus 8x plus 7. That is going to match up with this green graph. We've got x squared plus 8x plus 25. That's my red parabola up here. You see it doesn't, you can't even see it cross the y-axis, but it will cross up at positive 25. And then x squared minus 6x plus 9. That's this blue parabola. If you notice, all three of these have different types. The green parabola obviously crosses twice, the blue parabola crosses once, and the red one doesn't cross at all. So, when we talk about the number of real roots, the number of times it really crosses, we have that it crosses once for x squared minus 6x plus 9, that it crosses 0 times for x squared plus 8x plus 25, and it crosses twice for this one. Again, that's just how many times are these particular graphs crossing. Now, we all know the quadratic formula. We derived it in class the other day. The discriminant is actually hidden inside the quadratic formula. It's this piece underneath the square root. And that makes sense because when I have the square root of a number, if it's a positive number, there's two answers, or two real roots. When it comes out as 0, there's only one answer, it's 0. And when it comes out negative, that's when we'll have i's in our answer. Hence, not being able to see any roots. Let's take a look at those same, so again, the discriminant, it was in the quadratic formula, and it's that b squared minus 4ac. Okay, and what we'll do is that will tell us how many roots and what. It's also a nice way to tell if a quadratic's prime, because if b squared minus 4ac comes out as a perfect square, then the quadratic is factorable. So, we already said this had 1, this had 0, and this one had 2. When I do the discriminant, and again, the discriminant is b squared minus 4ac. b squared will be 36 minus 4 times 9 times 1, which will be 36 minus 36, which is 0. When I do b squared minus 4ac, I'm going to get 64 minus 4 times 1 times 25. And so we'll have 64 minus 100, which is negative 36. That means if I did this quadratic formula, I'd get the square root of a negative. That's resulting in no real roots. And then the last one, when I do that, I get 64 minus 4, 1 times 7, 64 minus 28, which is positive 36. Okay? So, what's happening is if the discriminant comes out positive, we have two real roots. If it comes out as 0, there's one real root with a multiplicity of 2. And if it comes out negative, there are 0 real roots, but there are 2 complex roots. There's 2 roots with i's in them. And when I say complex here, I mean having both a real and an imaginary component to it. Okay? That's it.